The next examples will deal with the leading coefficient other than 1, although this method does use or will work when the coefficient is 1. So the first step is the same. We'll look for the GCF of all of our terms and take that out in step 1. Step 2, we're going to multiply our leading coefficient, which is A, times our last term C, and we're going to look for the factors of the product of that answer that adds to equal our middle term, similar to what we did in the prior examples. But instead of just looking at C, we look at the value of A times C. We're going to rewrite the middle term as the two terms used in the pair from the step above. And then we're going to factor by grouping to finish our problem. So let's look at example 2a. So step 1 is to look for the GCF, and the GCF for this polynomial is just 1. So our next step would be to multiply our leading coefficient, which is the A, times our C, which is a positive 2. So 3 times 2 gives me a positive 6. And notice I wrote positive 6. Now what I'm going to look for, remember, is I'm looking for, since this is a positive, the signs are going to be the same. And the signs are both going to be positive since my middle term is positive. So the positive factors of 6, which is 1 times 6 and 2 times 3. Now I'm looking for the pair that adds to a positive 7. So 1 plus 6 is 7, and 2 plus 3 is 5. So my first pair, the 1 and the 6, add to give me the middle term, and 1 times 6 equals the product of A times C. So now I'm going to rewrite the middle term using these two factors. So I have 3x squared plus 1x plus 6x plus 2. Order does not make a difference. I could have written 3x squared plus 6x plus 1x plus 2. Now I'm going to factor by grouping. So I group the first two terms together and the last two terms together and remove the GCF, which is an x in the first group. That leaves me a 3x plus 1 and a positive 2 in the second group, and that also leaves me a 3x plus 1. Remember, when you factor by grouping, the terms inside the parentheses need to be identical. This is our GCF because it's a common factor. So we take out our 3x plus 1, and that leaves us with x plus 2 as our other factor. And again, order does not make a difference. You could have x plus 2 times 3x plus 1. Example 2b, 12r squared minus 5r minus 2. So I look first, to see if I have a GCF other than 1, and I don't. So I'm going to multiply my 12 times negative 2, and I get a negative 24. I'm going to write down all my factors of negative 24. So I'm looking for the pair that adds to a negative 5. So it's 3 and a negative 8 add to equal negative 5. So I rewrite my middle term. So I have 12r squared minus 8r plus 3r minus 2. Next, I factor by grouping. So I group 12r squared minus 8r, and I group the 3r and the minus 2 together. The common factor in the first group would be a 4r, leaving me a 3r minus 2. The common factor in the second group is a positive 1, and that leaves me with a 3r minus 2. Remember, those terms have to be identical. So 3r minus 2 is my GCF, and then 4r plus 1 would be my other factor. Our next example, negative 3x squared plus 16x plus 12. I look for the GCF for this problem, and the only thing that divides evenly into all three of these terms is 1. But since my leading coefficient is negative, I prefer it to be positive, so I'm going to factor out a negative 1, which changes the signs of all my terms. I'm going to temporarily ignore that negative 1, and I'm going to focus in on my polynomial inside the parentheses. I'm going to multiply my a times my c, so 3 times negative 12 is negative 36. And I'm going to write down all my factors of negative 36. So I'm looking for the pair that adds to a negative 16. So that would be a 2 and a negative 18. So I'm going to rewrite my polynomial, its middle term, 3x squared plus 2x minus 18x minus 12. Next, I'm going to factor by grouping, so I have 3x squared plus 2x plus negative 18x minus 12. The common factor in the first group would be x, and that would leave me with a 3x plus 2. Common factor in my second group would be a negative 6, and that would leave me with a 3x plus 2. I divided out a negative 6 so that my leading coefficient for both of the terms inside parentheses would be both the same, in this case positive. So my greatest common factor would be 3x plus 2. X minus 6 would be my other factor, and that negative 1 that I factored out in the first step, I would write in front of my first parentheses as a negative or as a negative 1. My next example, 16y cubed plus 24y squared minus 16y. The first step is to remove the GCF. In this case, the GCF is 8y. So when I remove an 8y, it leaves me with a 2y squared plus 3y minus 2. And again, I'm going to ignore the factor 8y temporarily. So I'm going to focus in on the 2y squared plus 3y minus 2. I multiply my a, which is 2, times c, which is negative 2. That gives me a negative 4. I'm going to write all my factors of negative 4 and choose the one that adds to a positive 3. And that'd be a negative 1 and a positive 4. So I rewrite my polynomial as 2y squared minus 1y plus 4y minus 2. I'm going to factor by grouping. Remove a y in my first group. That gives me y times the quantity 2y minus 1. And I'm going to remove a positive 2 in the second group, which leaves me a 2y minus 1. And again, what's inside my parentheses is identical and has to be. That's my GCF 2y minus 1. My other factor would be y plus 2. And remember, whatever you factor out in that first step needs to go in front of your parentheses. So my final answer would be 8y times the quantity 2y minus 1 times the quantity y plus 2.